The Pacific Northwest is a land filled with natural beauty. From its jagged coastlines and lush rainforests to the snowy peaks and pine forests of the Cascades, and finally the dry, desolate deserts to the east, it is a region with a vast amount of different ecosystems, climates, and landscapes. Over thousands and thousands of years, the landscapes of the Pacific Northwest are sculpted by wind, water, and tectonic shifts. But what if I told you that some of this beauty isn't natural? The forests in this area, and around the world, are constantly changing. Factors such as native or invasive species, disease, human interaction, climate, and wildfire all play a role in the ever-changing life of our planet's forests. Spanning the Oregon-Washington border is the Columbia River Gorge, carved into the land by a series of cataclysmic floods rushing towards the ocean from Missoula Lake over tens of thousands of years ago. If you aren't from this area, or aren't familiar with the gorge, you may have heard about it in recent years due to an increasing propensity for raging wildfires each summer. During the height of the most recent major fire in September of 2020, Portland faced an air quality index rating of over 530 for multiple days in a row, the worst in the world. Although there are a handful of elements that affect a forest development, we've begun to rethink our approach to how we should view fires, especially in light of recent events. Why are wildfires such a pressing issue today, and why might the beauty of these forests not be natural? To answer those questions, we have to look both into the history of how we manage our forests and the essential role that fire plays in the endless cycle of every forest's life. Jay Odenbaugh, professor of philosophy at Lewis and Clark College, focuses on foundational issues of evolutionary biology, ecology, and psychology.
So forest fires are really important. They're crucial to the development of forests through time. They've played an incredibly important role in the American West. I live in the Pacific Northwest in Portland, Oregon, and if you were to tour, say, the Columbia River Gorge or even Mount Hood, you would see some just amazingly luscious, beautiful green forests. Those forests have been shaped by fire, and one of the things that's particularly important about our forest is though they look extremely beautiful and lush and pristine, they're actually quite unhealthy. The one way to see this is to think about the history of fire suppression. So since roughly the 1930s, the U.S. Forest Service decided to basically put out any large-scale fire that appeared, which on the one hand is a good thing because it prevents homes from burning and it also often can save lives. But fire actually is really positive in many ways, and the most important way is that it's regenerative. So whenever a forest is old and aged, what happens is fire actually regenerates new life in that forest. So it can take trees that are diseased and old and it can remove them. It can introduce new trees, right? And new plants and animals create new habitat. As one of my kind of favorite examples of this is actually redwood forests in Northern California and Southern Oregon are often protected and not allowed to have any fire move through them. But the seeds from redwood trees will only grow and germinate under intense heat. And that's from a natural fire regime. So you can't essentially get new redwood forests without allowing for fire to move through them. In a way, forests that don't allow for fire are a kind of botanical mausoleum. You also, when you see a forest that has a sort of natural fire regime, the forest has a kind of mosaic pattern. Trees are of different ages. There's empty spaces in which new plant life can emerge. There'll be snags, so trees that will be habitat for other plants and animals and birds and so on. You know, forests are incredibly important to us, both for sort of aesthetic reasons, both for biodiversity reasons and in the sense of all the species that live there, but they also sequester tons and tons of carbon. So if you're worried about climate change, you should worry about the health of our forests. Forest fire is crucial for those forests. Now we're making it worse, right? When we emit greenhouse gases and we warm the average surface temperature of the air, those forests dry out, right? And it makes these fires that would have been normal under certain circumstances into megafires. And this is one of the big worries that we have in the West, and especially in places like the Pacific Northwest, where there are so many forests and so many trees.
This is what a recently burned forest looks like. At first glance, it's a charred, barren wasteland devoid of any color that may signify the presence of life. This forest is destroyed, charred, dead, unrecoverable. But wait, if wildfires are a common occurrence in nature, wouldn't all of our forests have been burnt to a crisp by now? In 2017, a teenager in the Eagle Creek area of the Columbia Gorge threw a firework down a steep canyon. This immediately ignited the dry forest floor and resulted in one of the most devastating fires in the Columbia Gorge in recent history. At the time, media outlets described the approximately 50,000-acre burn area as destroyed. Apart from a small handful of buildings that burned down, this couldn't be farther from the truth. Our public perception of fire is of something that destroys everything in its path, a force of nature that displaces humans and other animals alike, destroying homes and property and leaving forests as lifeless wastelands. But unlike the common narrative, fire, as a force of nature, isn't opposed to life, it's part of it. Fire clears out the upper canopy in forests, which allows sunlight to reach the ground. It provides snags in the form of partially burned trees, which act as homes for the multitude of animals that live in our forests. And these animals, despite what you may think, tend to do just fine during large fires. Birds can fly away, smaller animals take cover underground, and those that can't do either simply run away. Only a very small percentage of that 50,000-acre burn area around Eagle Creek burned at a high level of intensity. Many patches were left untouched or barely burned at all, as fire doesn't apply its heat evenly across its whole area. Even the areas that did face more severe heat will still recover. It may just take a little longer. How long exactly? This is that same area, only 3 years later. The multiple decades of aggressive fire suppression in the mid-1900s lined up perfectly with a relatively cool, wet climate cycle, giving the illusion that our efforts were succeeding. Only recently have humans been able to an extent, control fire, and our first instinct follows the classic sad story of our species: control it, suppress it, eliminate it. If it poses any danger to humans, it must be directly antithetical to life and nature as we know it. So, we created Smokey the Bear. Only you can prevent wildfires. Only you can stop this evil force of nature by, removing a few twigs from the underbrush that can serve as fuel? Our illusions of the success of fire suppression policies were only exacerbated by the fact that we really didn't know what we were doing. Some people claim that this is purely an issue of forest management, and that all we need to do is change how we manage these wild lands. Think about it critically though. Let's say that thinning our forests in order to prevent large fires really did work. It doesn't, but we'll get to that in a minute. Mount Hood National Forest stretches across more than 1 million acres of land in northwest Oregon, just next to the Columbia Gorge. In order to properly thin 1 million acres of forest, we'd have to construct new roads in order to get heavy equipment in and invest a gargantuan amount of time and resources into clearing efforts. And all the while we'd be spewing more carbon dioxide into our atmosphere, which only makes wildfires worse. Across this 1 million acres of land, how much would burn? How much of this cleared area would actually reap the benefits? Well, the 50,000-acre Eagle Creek fire would cover a measly 5% of this cleared area. That other 95%? Wasted resources, damaged ecosystems, unnecessary roads, and more greenhouse gas emissions. But wait, it gets worse. In order to ensure that a thinned area remains effective at slowing down or preventing fires, which, again, it generally doesn't, we would have to rethin this million-acre national forest every 5 to 10 years. Now extrapolate this to every forest at high risk of fire, and we would do orders of magnitude more damage to both our economy and our planet than if we simply let fires burn. In an intense fire, the larger trees are usually not the main source of fuel. Many trees have fire-resistant bark, and only a fraction of them actually burn and release carbon into our atmosphere. The real fuel is the smaller shrubs and ground cover on the forest floor, which burn quickly and release a comparatively large amount of smoke. Thinning trees to reduce fire danger in a forest, therefore, is generally ineffective, and to adequately clear the true fuel for wildfires would take even more resources than our previous hypothetical. So if forest management isn't the answer, and never has been, what's the true cause of the increasing severity of wildfires we've seen in recent years? As with many environmental issues we're facing today, the answer is climate change. As surface temperatures increase and weather becomes more severe, the risk of large wildfires increases dramatically. Years of extended drought conditions led to the tinderbox-like conditions in Eagle Creek, and only 3 years later, California and Oregon were bathed in a suffocating orange glow for days as both states battled extreme fires. In early September of 2020, a 60-day period of high temperatures and no rain combined with a 3-day period of extreme wind. These two compounding extremes led to a dramatic increase in fire danger, and smaller, usually harmless fires turned into massive burn areas. In 2020, more of the Oregon Cascades burned than the previous 36 years combined. And, as our climate grows warmer and drier, these fire-prone conditions will only become more common. Despite the increasing danger of what may seem to be an unbeatable force of nature, trail recovery efforts in the gorge have played a crucial role in allowing more people to come back and visit these previously burned areas for themselves. 2 years ago, I took a course called Environmental Law and Policy, in which one of these people who has done trail recovery work in the gorge gave a talk. Much more than just a good Samaritan, he knows the intricacies of wildfires more than almost anyone else. I reached out to him while working on this film, and he showed me some burn areas of the gorge that most people will never see, and how those areas have recovered.
My name is Ralph Bloomers, and I'm an advocate for fire-safe communities and natural forest recovery. And about 20 years ago, I had my first experience where I was called by a longtime professional in prescribed fire to forest in eastern Oregon. And he had reported that many of the trees that had been burned by fire were still alive. And he worked for the Forest Service, and he was essentially blowing the whistle, saying that their claims that those trees were dead and dying were wrong. So I went out there and brought a botanist along with me, and I just had an amazing experience in this burned forest. where most of the trees were alive, the undergrowth was burned. And that sort of began my journey of discovery with fire burned areas and a lot of work with experts and in the field over the last 20 years. 5 years ago, when the Eagle Creek fire was started in the gorge with a firework in Eagle Creek, there was a really heavy wind, and the fire blew from about four miles away this direction with an east wind at 30-mile-an-hour east wind, probably with a 3 to 4 mile an hour ground speed. And the fire perimeter was 50,000 acres. And the news media was saying 50,000 acres is destroyed. Well, you come out here and you find in the subsequent years that within that fire perimeter, only 8,000 acres or so is burned very severely. And what those forests are these beautiful young patches of new growth, and they're full of potential and they're full of life. So what I've done in the last 5 years is wildlife camera traps, time-lapse photography in various spots in the gorge, primarily on state park land and then some private inholdings. I spent time with school kids who were evacuated in Cascade Locks, in the classroom and in the forest, and many of them 3 years after the fire had still not been in the forest. And it was magical for them. They got to go on a burned forest treasure hunt, and one of the girls remarked, "It's over. It's over." For her, the fire was still very real and present in her life 3 years later, but when she saw that the place around her was coming back, she just really responded to that. I've done a lot of different things that have allowed me to get in. One of my favorites is trail recovery work. So you get slides on them, you get down trees, you got to fix the tread. And I've done those with Trail Keepers of Oregon, Pacific Crest Trail Association, and just these super dedicated volunteers that have put in thousands of hours, worth hundreds of thousands of dollars to bring back these trails. And what I love about that group is they are here for the forest. They don't see the forest as just being here for them. We need more people that say, I'm going to pitch in, I'm going to help out, I'm going to do my part. So I've set up wildlife camera traps, and, I have captured bears and cougars with kits, bobcats, elk, deer, cougars hunting, birds when the cameras get pushed to the ground by bears hunting for worms. I have captured so much life in the severely burned, allegedly destroyed patches of forests that it's been just such a fantastic last 5 years of my life to just see that. And so I've seen it go from completely brown to green and full of life again. And why that's special is not just to me. I think that there's these strongly rooted cultural beliefs about fire. Fire kills all wildlife. Fire destroys the forest. And fire can and must be managed by man, either through suppression or through altering the forest before fire comes. Well, most wildlife survive fire. Some succumb, but it's really a small percentage. And the wildlife camera traps have shown us that. Now, with respect to fire destroys the forest, fire destroys homes and can destroy communities, and they don't grow back. But for the forest, the landscape is still here, the soil's still here, the carbon is still here. Most of what's taken in the fire and consumed is the fine material. And then in many cases, you still got the mosaic. You got the green trees, you got patches of low severity, no severity, moderate severity, and high severity. It's a mosaic, it's a carpet, it's a quilt. So I like to think of the severely burned forest, like many fire ecologists do, as a young person full of potential, full of life. So I am a big advocate for making sure communities are prepared so that we can protect natural landscapes and let fire do its thing in those natural landscapes without being fearful that we're going to lose our communities. And And we're seeing, in an increasingly hot and dry climate, the limits of our ability to do that. Since the mid-1980s to present, we've had periods of extended drought. And that creates a really high energy release potential in the vegetation on the landscape. You get an ignition, power line coming down in a wind event, trailer, arson, carelessness, campfire, or lightning strike, which is 1/10 of them. And it tests our limits of control. We can't fly aircraft in that. Fires grow so big that we're just corralling them away from communities if we get lucky enough to do that. It's no longer vegetation, which is what's referred to as fuel, that's the primary driver of these big fires. It's wind and drought. And it's in the extreme conditions, which is about 3, 4, 5% of the fires, that we see the most structure loss, the most rates of spread. And so we're seeing a lot more of these amplified, and I like to say wind and drought influenced fires, because climate is wind and drought over time. But really what we saw was pretty typical in the historical record, because this is supposed to be a rainforest, supposed to be mostly wet. So it takes a situation of extended drought and a big wind event and an ignition, and then that's when you have 100,000 acres, 200,000 acres burn. And so, there's just that kind of thing. Again, I would bring it back to, we just have to remember we're here for the forest. In this landscape, the forest is not here for us.
We also visited Nasaika Lodge, perched high atop a cliff overlooking the gorge. It's usually quite a long hike to get here, but having access to restricted forest roads and a burly Land Rover proved to be the more comfortable option. Unlike the two smaller buildings next to the lodge that burned down in the Eagle Creek fire, Nasaika Lodge survived. Secluded in the middle of a forest and facing a raging wildfire, how did this building survive while the others didn't? The answer could be the key to the next major step in how we approach protecting ourselves from fire.
Researchers for a number of years have figured out what it is that are the causes of ignition of a house. What's the physics of that? And it's really fascinating, because for a long time we focused on the vegetation around the home, the defensible space, but not on the actual characteristics of the structure itself and how it burns. And what they found is it's the embers in a wind-driven or a firestorm or a wildfire. They get pushed into the attic through the venting. They get pushed into the crawl space through the venting that helps that home breathe. And they ignite the structure from the inside out. Or they ignite the fine material that's in a gutter, and that gutter catches on fire, and then it catches the eaves of the house on fire. And what's amazing about Nasaika Lodge here is this is in a high severity burn patch. All the trees are killed around here, if you look at it from the air. And the topography is, it's on a super steep slope, 1,800 feet up from 2,000 feet up from I-84 and the gorge and the Columbia River. And the fire came from Anianta, raced up the hill here, crowned out, killed all the trees, and this lodge survived. Well, you look at it and you see why. It's got a concrete porch and a stone walls. It's got huge beams. It's got wood up there, but it has no gutter. It has no crawl space with no venting. It has no venting there's no attic. So there was no way for embers to penetrate. There was no material next to the structure that would allow the flammable material to ignite, and they just lucked out with the way that they built. I don't think they built with fire in mind, but the thing survived.
Humans are just animals. We don't have complete control over nature. We don't even have a complete understanding of it, and we likely won't for the foreseeable future. What we can do, though, is minimize the harm that nature can do to us while also optimizing for the well-being of our planet and the rest of the animals that live here. Wildfires do present a legitimate danger to us, and as we continue to warm our planet, that danger will only grow. However, aggressive fire suppression is not the answer. It restricts our forests and only worked for a few decades in the past due to favorable climate conditions. Thinning of forests is also not the answer. Even without taking into account that it's rarely effective, properly doing so would be prohibitively expensive and require an unjustifiable amount of labor and construction, all while further damaging the forest that we should be trying to protect. Fire isn't nature's enemy. It simply is. Yes, it can kill plants and animals, and it can destroy property and displace hundreds or thousands of people from their homes. But it's also crucial to the survival of some of our forests, and provides undeniable benefits for biodiversity, forest growth, and more. The more we try to fight fires, the harder it will become. That's why we need to accept that we have to live alongside fire, not against it. We need to let forests burn and regrow, let nature take its course, but allowing fires to burn and protecting ourselves isn't mutually exclusive. Measures such as clearing areas near roads to create boundaries and taking steps to protect our houses from fires are relatively cheap and easy and provide a huge amount of protection. As with many environmental issues today, climate change is at the heart of the debate surrounding wildfire. This isn't an isolated issue. It's a sign of things to come, and as our planet continues to warm, we have to adapt with it.